Hello, greetings YouTube audience. This is a response video to EW926, his very kind, and he's a true philosopher gentleman, his very kind response to my series attempting to affirm the continuum hypothesis, and he made some points that I would like to address. In fact, he's acknowledged to me in private messages a few of the points that I made to him, and that he's going to do some kind of correction video, and that's fine. I just want to respond to the points that he's made now. First of all, I want to say one thing that no professional mathematician would disagree with, and that is EW926 stated that the rationals are a set, an infinite set between the natural numbers and the real numbers. Cantor, in fact, proved that the natural numbers are countable with respect to the rational numbers and vice versa. As paradoxical as that might seem, well, wait a second, there are more rational numbers than there are natural numbers. It would seem like there are infinitely more. And yet it is, in fact, the case that the natural numbers are that you could actually take each and every single possible fraction and have a one-to-one correspondence with natural numbers. Cantor's very famous proof of this. I covered it a little bit in parts 1 and 2 of my argument to affirm the continuum hypothesis. I don't believe I did it justice. However, at the very same time, I would go to Amir Axel's book and other books on the subject, and they will definitely show the argument demonstrating that natural numbers and rational numbers really correspond to the same level of countability. Now, the reals are would be the greater level of countability, or the continuum. Okay. And so the question of the continuum hypothesis is there a set that could possibly exist between the two of those that might conceivably be constructed that would exist as a level of countability between the rationals and the reals? Or even if we are never able to construct it, can we disprove the possibility of that set existing between the, let's say, the rational numbers and the real numbers? And that's the question at hand, and that's the question that has been proven undecidable with respect to set theory axioms, but it is potentially provable if there is an axiom that is accepted in addition to those. Now I want to address the question of limits and the whole idea of, well, what is 0 times infinity? And my good friend, and I do mean friend because I want to consider him a friend, EW926 has acknowledged that the undefinability